Hello and welcome to AWS training. My name is Saif Mandlek. Today we'll be starting our training with the very basics of what is cloud computing and so on. So things that we would be covering in today's module is what is cloud computing, the essential characteristics of cloud computing, as in metered reading and so on. We'll be talking about benefits of cloud computing. Why should you actually move to cloud? We'll talk about the different deployment models, as in a public cloud, a private cloud, what is a hybrid cloud. We'll then talk about the different service models. Some services are categorized as PAAS, platform as a service, infrastructure as a service, software as a service, and serverless computing. So we'll understand that. And then in the end of this module, we'll be talking about the different services that are available. And here I'll take an example of AWS, Amazon Web Services, and the different services that it provides, core services that can be used for the different core use cases. All right. So moving on, let's now understand what exactly is cloud computing. Now, there are multiple definitions of cloud computing over the internet. I find it easier to explain it in just a one-liner. Any cloud computing is nothing but a bunch of services, a collection of services that allows you, its user, to create different IT resources in a data center, right? So let's understand this from a diagrammatic standpoint. So basically what we are saying is every cloud provider, bare minimum, will have a data center, and usually each cloud provider like Amazon or Microsoft Azure, Google GCP will have multiple data centers all around the world, and each data center obviously will be having physical servers inside it, right? So there will be multiple servers connected to each other over the network, air conditioning, power 24 by 7, and so on. So that is one part of what is cloud computing. You will have a data center part with physical servers. Now, along with that, what a cloud provider would provide is a bunch of services. All right. And I normally represent services in triangle. What you as a customer can do, what you as a customer of this cloud provider can do, is you can make use of these services to create virtual resources in the cloud provider's data center. So what kind of virtual resources are we talking about? Let's say you have a file, a very important file, maybe a tax document or any application related files. Now, instead of storing those files in your own data center, in your own laptop or desktop, what you can do is maybe the cloud provider will provide you with one service, and this second layer we will call it as the services layer. So maybe the cloud provider will have a service to upload files, and you as a consumer can make a call to this service, upload your file. The service will then save your file in the cloud provider's data center. That is one kind of resource that you can store in the data center. Other kind of resources, let's say you want to host your company's website. So basically you require a web server, that is maybe a virtual machine which will have a web server software running, and you will deploy your HTML, JavaScript, CSS code. So again, here your cloud provider can come for aid. The cloud provider would have a service which would allow you to create virtual machines, right? So you as a consumer or a user of the cloud can make a call to this service and say, hey, I want you to create a virtual machine, maybe with 4 virtual CPUs, 8 GB RAM. And this service will then create a virtual machine in one of the physical servers in the cloud provider's data center. Let's say you have hosted your website. Now you want to Now you need a database for your web application. Again, you can use your cloud provider service. So maybe there would be a service, and maybe there would be a service which will allow you to create databases in cloud providers data center. You as a consumer can make a call to this service and say, hey, I want an Oracle database, and this service would then create a Oracle database for you in your cloud provider's data center, right? So it's as simple as that. What is cloud? Basically, your cloud provider will have data centers for you and will give you a bunch of services through which you can create virtual resources in your cloud provider's data center. Or in short, people say we create resources or store resources in cloud. This is what it means. Now, these services typically are publicly available services. They are RESTful services. You can make HTTP calls to these services. Now, how do you make calls? How do you interact with this service? One way of doing it is maybe in your laptop or desktop, you write a code, a C# or a .NET code. And from this code, you interact with these services. That is one way of doing it. Alternatively, if you are not a programmer, then your cloud provider will provide you with a website. So I'll just clean this off. Alternatively, if you are not a programmer, if you don't want to do programming, then your cloud provider will also provide you with a website, and we normally call it as a web console. From your laptop or desktop, you can log into the web console. Let's say upload your file to the web console. This web console means this is a website, a UI. The web console will make call to the appropriate service, and the service will create the resource. Let's say if you want to create a virtual machine, again from your browser, you will log into the web console, use the UI of the website saying, please create a virtual machine for me. It would be the web console that would interact with the appropriate service that would create a virtual machine for you. Likewise, if you wish to create a database, if you wish to create a database, what you can do is again from your browser, use the console, say I want to create a database, the console will interact with the service and create the database for you. So this comes the third third part of the cloud solution, right? One is the data centers would be provided or would be there where your virtual resources would be created. Bunch of services would be provided to you through which you can create virtual resources. And then to make your life easier, maybe a UI would be provided by means of a website, a web console. Now you don't have to necessarily use the UI to interact with the service as we drew in the earlier diagram. These are all publicly available service. You can directly write a .NET code, a Java code, a Node.js code to interact with the services directly, or maybe you can make use of some tools provided by your cloud provider, and you can run some scripts that can interact with these services directly. Regardless, long story short, bunch of services, you send requests to these services asking it to create virtual resources. The service will create the virtual resource for you in one of the data centers. It would be you who would be telling what resource you want. If you want a virtual machine, how much virtual CPU, how much RAM. It would be you, when you send a request, you will say in which data center you want the resource to be created, whether in a Singapore data center or a North Virginia data center or a Mumbai data center, right? Now, moving on. So this is the very basic of the different parts that are involved when you typically want to use a cloud solution. Now, Each cloud solution should bare minimum have at least these 5 characteristics, right? Which would qualify it to be a cloud solution. Now let's talk about what are these characteristics. First, it should be the cloud solution or the cloud offering should be on demand and self-service. So on demand means what? Let's say if you want to create a virtual machine, you need not, ask your cloud provider to give you a virtual machine for 1 week, 1 month, 1 year. No. If you want it now, you send a request saying, hey, I want it now at this very moment, on demand, right? You don't have to sign a contract of 1 week or 1 month, 1 year, 3 years. All those days are gone. On demand, you just come, you say, I want it now. Your cloud provider should be good enough to provision and give you the resource at this very moment. Maybe few minutes would be taken for provisioning of it, but then you should be able to use it. The second characteristics, it should be self-service, right? So that means the services should be available that you as a customer can use it yourself, send request yourself. It shouldn't be that you are dependent on a customer service executive. It shouldn't be like you have to pick up a phone call, talk to someone saying, hey, I want a database, I want a virtual machine, and so on. You should be able to use these services yourself whenever you need it and create the resources as per your requirement. Moving on to the next cloud characteristics, broad network of access. That means your cloud provider should give you different ways and popular means of interacting with the service as well as with the resources. So, example, we said that services would be provided to you. You as a customer can directly interact with the service, right? So the different ways of interacting with the service is, one is the web console. You can use the any popular browser, log into the website, and through the website interact with the service. Or you can write your .NET Java code. All these services are RESTful services. Their endpoints, their request parameters are all published, right? So you can use your normal RESTful libraries to make calls to these services and send your request. So this is as far as using the service is concerned. Now, once using the services, you have created the resources. How do you use the resource? You need to access the resource, right? Even accessing the resource should be made very easy to the customer, which it is. Let's say if you have created a virtual machine, then you can remote log into that virtual machine from your laptop. Maybe your cloud provider will give you a public IP. You can use that public IP and connect to your Windows machine using RDP client, remote desktop protocol client. Or if you have created Linux machines, then you can use any SSH client to establish a remote connection to these virtual machines. Let's say if you have created relational databases, so then again, these created relational databases, the cloud provider will give you a public endpoint. Now these are typically DNS names. You can use these in your connection strings, in your usual JDBC, ODBC, OLEDB connection strings to connect to the database, which is created and running in the cloud, and then create tables, insert records, and so on. Moving on, the third characteristics, resource pooling. So basically what this means is you'll have a common pool of resources. So like we said, in the data center there will be 100, 200 different servers, and in these servers multiple users or different users of your cloud provider can create different resources. So let's say in case of a virtual machine, you asked for a virtual machine, your VM is created in this particular physical server. Maybe some other customer also asked for a virtual machine and that virtual VM for other customer also gets created in the same physical server. So the resources, there are pool of resources, physical resources that get shared across multiple clients. Now, cloud providers do give you an option to have dedicated resources as well, where the physical resource is not shared with multiple customers but are dedicated to you as well. But that is an additional offering which they may give, and we'll cover all that in our future modules. Moving on to the fourth point, rapid elasticity. So here what we mean by rapid elasticity is the cloud provider should have enough capacity to support your requirements, right? So let's say you have saved your files. Today you have saved uh, 10 GB of data, 10 GB of files. Now all of a sudden it's a tax filing time and you get another 50 GB of more tax documents and you need to save it. Now whichever storage service you are using from the cloud provider should be elastic enough to accommodate the storage of additional data. It shouldn't say, sorry, I don't have enough space for storing your files, right? It should be elastic. It should allow you to store more data, or it should allow you to remove your data, and you will be charged accordingly to how much data you are storing. Another aspect of elasticity is when it comes to these virtual machines. Let's say you have created two virtual machines and hosted your company's website, maybe an e-commerce application, which is good enough currently for maybe 10 or 20 concurrent users. Now imagine a case where in festival season your user load increases and you now have all of a sudden 100 200 concurrent users. Now in such cases you would require more web servers. Instead of 2, you may require 10 web servers. Your cloud provider should be good enough to allow you to create those additional 8 web servers. In fact, a lot of cloud providers support something called as auto scaling. And in that, what happens is if your user load increases, automatically web servers are added. If your user load decreases, automatically web servers are terminated. So that is what we mean by the elastic nature. Imagine a rubber band, you apply more force, it expands, you release the force, it contracts. Same way, you have a fleet of web servers, the user load increases, more web servers are added, the group count increases. If your user load decreases, few web servers are terminated. And the final characteristics, the resources that are created should be measured, right? Why? Because once you create resources, virtual machines, the cloud provider is eventually going to charge your credit card for your usage. When you save files for the amount of data that you store, the cloud provider is going to charge you for your storage, for the databases that you create. It's going to charge you. So how is it going to charge you? That bill should be very transparent. A cloud provider should very clearly tell you that, hey, I am charging you these many dollars and these many cents for a virtual machine that you ran for maybe 4 hours and 20 minutes. So all the different resources that you create should be metered very carefully, should be an account should be kept of it, and accordingly you should be charged. Moving on. Next, we will talk about the different deployment models when it comes to cloud. So this example that I was giving, where you have a bunch of services that allows you to create resources in your cloud provider's data center. Now, if these services are available for public, that means I, as a customer, can interact with this service, create resources. Some other user who has a valid debit card or credit card can use these services and create resources in the cloud provider's data center, right? So there is no restriction. Anyone Anybody and everybody who has a valid credit card or debit card can create an account with a specific cloud provider and start using its services. That is what is meant by a public cloud, a cloud offering available for the public. Anyone can use it. Now, there is something else called as private cloud. Nowadays, it is also called as on-premise cloud. Now, what does this mean? So let's take a step back. So basically, what are we saying? What is a cloud solution? Just a bunch of servers, physical servers, right? And then a bunch of services that create virtual resources in those physical servers, right? Now, if you wish, you can be a cloud provider yourself. You can start your own cloud offering. There are open source softwares available in on the net, and one of the very popular open source software is OpenStack. You can install this software if you have some 10, 20, 30 physical servers. You can install this OpenStack software in your data center. What it would do is it would create a bunch of services in your data center, and then those services would create virtual resources in your own data center. So right, so you can use OpenStack to have a cloud offering in your own corporate data center. Who will use that cloud offering? Employees of your own company. I cannot use it. It won't be accessible to me on the internet. I will not be given access to it. But employees of your own company can log into the corporate network and start using these services. At least they can start creating resources on demand in a self-service way. So a cloud offering that you set up yourself in your own data center is called as private cloud or on-premise cloud. Nowadays, a lot of this public cloud providers also give you a private cloud offering or on-premise offering. Example, Microsoft Azure allows you to have a set of services that would create resources but in your own data center. VMware has a public cloud called as, I think, vCloud, and it also has a private cloud offering where if you call them, their team would come up and set up a cloud in your own data center. Again, that cloud is the private cloud or the on-premise cloud. AWS lately has an offering called as AWS Outpost, with which, again, using these services, you can now start creating resources in your own data center rather in AWS's data center. Moving on to the next deployment model, we have something called as hybrid cloud. Now, hybrid cloud. So before that, let's come back to private cloud or on-premise cloud. Why would you go for an on-premise cloud or a private cloud? What are the use cases? Let's say you already have your own huge data center setup with hundreds and thousands of servers. You already have a good experienced team of professionals, of administrators who can manage these servers. You have a reliable power supply, air conditioning, and everything. Now, you don't want to mess up with it. You're pretty happy with it. What you want to do is you want to facilitate your employees this capability of self-service on demand creation of resources. So here you don't actually want to go to maybe AWS or Azure, but continue to use your own data center, but at least deploy a private cloud solution onto it so that your employees can now start creating resources by themselves. The another reason why you would also go for a private cloud offering is maybe your industry standards uh, dictate, govern that hey, the data that you would be storing is very confidential, and you should only be storing the data on your own data center, which is secure. You should not be storing it in someone else's data center, regardless of whether it is Amazon, Azure, Google, doesn't matter. store it in your own data center, preserve it. So then in that case, you have no other option but to maybe go for a private cloud deployment. Moving on, we'll now talk about something called as a hybrid cloud. Now, hybrid cloud is when customers use both. When you talk about an application, each application would have different components, different subsystems. And when you deploy one subsystem in a public cloud, the other part of your application, the other subsystem in a private cloud, that or in a private data center, then that makes your solution as a hybrid cloud. Example, let's say you have a web application which is accessing a database. Now, your company or your industry standards say that it is okay to deploy your web application in someone else's data center, but the data that you are going to store in your databases, that has to be in your own private data center. Now, in this case, what you'll do, you'll create your web servers in a public cloud, let's say AWS or Azure, which would then connect to databases which would be created in your own data center. So that is what is meant by private cloud. Moving on. Now when we talk about cloud computing, there is something called as service models, and here we have IAAS, infrastructure as a service, platform as a service, software as a service, and serverless offering. Now what does this mean? So what did we say? Any cloud offering is nothing but a bunch of services, right? Each service having its own capability, each service creating a particular type of an IT resource. Now, from these bunch of services, now what we are saying now is theoretically, we can categorize few services as IaaS. Some other services can be categorized as PAAS. IaaS stands for infrastructure as a service, platform as a service. Some other service can be categorized as software as a service, and some other services can be categorized as serverless. So now let's understand what are the services that what are the features of a particular service that would categorize it as a IaaS versus PAAS versus SaaS and serverless. All right, so let's take an example of AWS. Now, AWS has a service called as EC2, Elastic Compute Cloud. This service allows you to create virtual machines in AWS data centers in the physical servers, right? Now, what this service does is it gives you the infrastructure, the physical infrastructure, as well as creation of the virtual machine will be done for you. Now, once your virtual machine is created, thereafter maintenance of these virtual machine, that means initially the operating system will be pre-installed, but thereafter, if you want to apply some security patches, if you want to apply some minor upgrades, you will have to do it yourself. You as a customer need to use your laptop or desktop, and you need to establish a remote connection, either an RDP or an SSH connection, remote login to your virtual machine, do all the maintenance work. If you want to use this virtual machine for hosting your web application, then you will have your code, and you need to establish a remote login connection and deploy your code onto the virtual machine created by EC2. So there you see what's happening. The infrastructure is given to you, and thereafter the maintenance of that virtual resource is your responsibility. So this service gets categorized as IaaS, infrastructure as a service. This service gives you the required infrastructure of the resource creation. Thereafter, maintenance is your headache. Now, there is other service in AWS called as Beanstack. Even using this service, the output of this service is a virtual machine that is created in a physical server. Okay, but there is a difference between EC2 service and Beanstack service. Now, for Beanstack service, when you make a call to this Beanstack service, what you can do is you can ask it to create a virtual resource for you. But along with that, you can also say that, hey, I want a virtual machine of a certain platform. I want a Windows machine with .NET platform or a Linux machine with Java Apache platform. And hey, by the way, this is my code of my web server. Please also deploy my code onto the virtual machine. Now it would be the service that would not only create the virtual machine for you, but it will also give you the platform, right, where it will deploy your application code onto your virtual machine. So you have your website running. Okay, so that's when this service gets categorized as a PAAS, platform as a service. It is giving you a web deployment platform. It is allowing you to upload your application code, and it is the Beanstack service that will take the responsibility of deploying your application code. You don't have to do it yourself. So this service gets categorized as a platform as a service. Another example in AWS of platform as a service is called as, there is a service called as RDS. Using this service, you can create a database in a virtual machine, right? And AWS calls this virtual machine as DB instance regardless. Now we are talking about platform as a service. Now, what are the features of this RDS service? Why does it get categorized as platform as a service? Because it will not only create the database for you, but it will also give you it will also perform some administrative stuff for you. It can automatically apply minor version upgrades. It can take backups of your database. It can deploy your database in a high availability environment, and it can provide you scaling. We'll talk about all these features more in detail when we come to the RDS module. Regardless, coming to PAAS. Now this RDS service gets categorized as a PAAS because it takes the responsibility of maintaining the platform for you, taking the backups for your database, automatically applying the minor versions. Whereas on other hand, instead of using the RDS service, let's say if you use the EC2 service to create a virtual machine, right? Which is of course created in a physical server, it would have been your responsibility then to remote log into this virtual machine and install a database onto this virtual machine, right? Why? Because EC2 is an IaaS, infrastructure as a service. There later installation, maintenance of your database, you'll have to do it yourself. Now, from this explanation, you'll obviously say that, hey, if that's the case, I'll always go for PAAS, right? Because my responsibility is reduced, the service is taking care of more and more tasks, and it's none of my headache. Yes and no. So it depends on two factors. One is agility, and other is control. See, the more responsibility you give to a service, the less control you have. Okay, so in other words, now when I was talking about RDS, which creates a database for you and takes a backup of your database, typically you would go for RDS if you require a database. But RDS or other platform as service offerings have their limitations. Example, RDS supports only 6 databases. Now suppose if you need a Sybase database which is not supported by RDS, then you have no other option but to use the EC2 service, which is IAAS. EC2 service to create your virtual machine with Sybase database onto it. Now again, coming back to RDS, the databases that you create using RDS service has certain limitations. Example, if you create a Microsoft SQL Server database, it does not support stored procedures written in .NET language, or it does not support linked databases. Just ignore if you don't understand this all now. What all I'm saying is PaaS offerings will have its own limitations and you will have less control. Like in RDS, the virtual machine where your database is created, you don't have access to that virtual machine. You don't have an operating system access. So from a solution standpoint, if you are okay with those limitations, then the advice is to go with PaaS offerings because they are faster and less maintenance. But if you require that additional control, then go for IAAS services like EC2 in AWS and put a bit of more effort, but also have that much more control. Moving on, in cloud service model, we then have something else called as SaaS, which stands for software as a service. Now, this is nothing new to cloud computing. We have been using SaaS for quite some time now. Let's say if you use Hotmail to send emails. What is Hotmail? A SaaS, a software as a service. Or Gmail, it's also a software as a service. Likewise, we said cloud providers give you different services. Some services can be categorized as SaaS. Example, AWS has a service called as SQS, Simple Queuing Service, which allows you to create queues. And through the service now you can put messages into the queue, retrieve messages from the queue. You don't have to worry about the infrastructure and so on. So these kind of services get categorized as software as a service, SaaS offerings. Now moving on, and very important lately is something called as serverless services. Now what does that mean? Okay, let's take a case of AWS itself. Just a while back I said if you want to save your file, you can use a service, and in case of AWS there is a service called as S3. You as a user can provide a file to this S3 service saying that, hey, this is the file, please save it in your data center. The S3 service will do the needful. Your file will be saved in one of the AWS data centers, right? All you have to do is use the service and your files are saved. To retrieve the files, all you have to do is use the service to retrieve the files. Though behind the scenes servers are involved, though behind the scenes your file is saved in a server which is accessing some hard disks, you don't have to worry about it. So S3 gets qualified as a serverless offering. Now some would raise an eyebrow and say, hey, it also gets qualified as a software as a service. You can just use it to save files, retrieve file. Yes, but the point of serverless services are there are no servers involved. A more apt example of serverless offering, rather I should be using, is there is another service called as in AWS called as Lambda. Now what you can do with this Lambda services, let's say you have a code that you want to run that picks up high definition images and creates a thumbnail of that of those high definition images. You can use this Lambda service and upload your code. What Lambda service will do is deploy your code somewhere somehow. You don't have to worry about it where your code gets deployed. All right, all you have to do is just upload the code, and the next thing that you have to specify is you have to specify the event, the trigger. When should this code run? Let's say you will say, hey, run a code when in your data storage one file is saved. You can specify this event. The Lambda service will execute your code when this event occurs. All right. And more importantly is, how do you get charged? Let's say your code runs only for 300 milliseconds. You get charged only for 300 milliseconds. So this service is a very good example of a serverless compute service. Where it is compute service, that means it is giving you the compute power. You specify, you give your .NET or Java code or Node.js code. Your code gets executed on some server, maybe a virtual machine, maybe a container, maybe a physical server, but you don't have to worry about it. Neither do you have to pay for that server, virtual server, or the physical server where your code runs, right? So that is why serverless. From a customer standpoint, serverless. The customer is not dealing with servers. But what you are assured is your code will be deployed somewhere. Your code will execute when a certain event occurs, and you will be charged only for the amount of milliseconds that the code runs. So comparing this to maybe a virtual machine that you create, if a virtual machine is running 24/7, you are paying for 24 hours of running that virtual machine because you have deployed a code in there. Maybe that code is not executing, doesn't matter. The virtual machine is running, you'll have to pay for it. Whereas here, if your code is just deployed, it is not executing, it is not running, you don't have to pay a single penny. Right? You don't have to worry about servers, you don't have to manage servers. That is why these kind of services gets categorized as serverless services. Moving on. Now we will talk about why. Why should you go for cloud? We talked about all these capabilities, features, so on and so forth, services, physical data center, virtual resources, and so on. But why, dude? Why should I go for a cloud offering? Why shouldn't I just continue to use my existing data centers and my existing servers? So, point number one, cloud offering gives you immense speed and agility. What we mean over here is you don't need to have the capacity ready in your data center. If you require 10 web servers, immediately create 10 web servers in a cloud provider's data center. If you want to use um, if you want to use some solutions like machine learning, artificial intelligence, all these kind of uh, projects require huge infrastructure setup. If you can end up doing that, but that would be a time consuming process, whereas you can just use it within a few clicks, within a few minutes. If you want a machine learning kind of a solution, or if you want to have a big data setup kind of a solution, you can do that quickly using cloud offerings. You have the agility from a licensing standpoint also. If you plan to try some certain new software and certain new version, imagine you using it in your own data center, requesting for the license, procuring the hardwares, and so on and so forth. Pain and time consuming tasks. Whereas here, you just do it in few clicks. You have the elasticity that your cloud provider provides. So we just talked about elasticity, right? If you want to store 10 GB of data, store it. Even if you want to store 100 GB or 100 terabytes of data, your cloud provider will allow you to store it. If you have two web servers, if you require two web servers, no problem. Even if you require 10 web servers, you can create it as your load increases. You can delete your web servers as your load decreases. The elasticity aspect of your cloud computing. Now with cloud, you don't have to guess capacity, right? So earlier when we were in on-premise, and if we had to deploy any new application, we used to do this elaborate capacity planning exercise where we would vigorously interact with the business users, try to find out what would be the peak capacity, right? Maybe the peak capacity is 20 concurrent users only for 1 week, but that would be our reference level. We'll further add buffer to that peak capacity, and then we will provision servers which would be of that size so that it can take care of that, uh, you know, time limited peak capacity scenario. Such a waste of effort as well as resources and money. Just maybe for a peak load of 1 week, 2 week, you are provisioning servers and running them idle for 1 year, 2 years. Whereas here in cloud, now when we typically deploy our applications, we have stopped doing this elaborate capacity planning exercises. We just deploy our applications with medium sized servers with a guesstimate. What we then do is we keep an eye on those servers. We monitor those servers. If we realize that those servers are running hot, if they are overutilized, it is very easy to increase its size from a 4 virtual CPU to a 8 virtual CPU or a 16 virtual CPU. Because you are in cloud, it's so easy to change your resources, its size as well as the number of resources. We had to do that earlier capacity planning because provisioning itself, procuring new hardware was such a painful task. Here, no such case. If I want bigger servers, I can create it in few clicks. If I have provisioned more hardware, if I want smaller servers, I can downsize my servers as well. If you are moving to the cloud, needless to say, now you don't need to do elaborate capital investment upfront, right? Procure 10 20 servers with your licensing, have a big administrator team, have your networking set up, your power, your air conditioning, and so on, because all that is already done in the cloud provider's data center. All you are doing is using that infrastructure and paying a monthly bill, so your capital expenses are reduced. Of course, you will be paying monthly bills, but at least you don't have to do a big upfront investment. Cost savings, very important feature of cloud computing, right? You require server for 2 hours, you create it, use it just for 2 hours. Compare that with your on-premise where you purchase a server, that's it, you are married to it. Even if you don't require it, it will be sitting there idle. Even if it is not powered on, at least it will be consuming your real estate space, or you sell it off at a very cheaper price. Compare that to if you are in cloud, you require servers for maybe 15 days, use it for 15 days, terminate it on the fly, and that's it. You don't have to pay anything for it. Similarly comes with licensing cost also, very important aspect. Now, generally, when we purchase licenses, maybe if you require license for a project, even for 2 months or 3 months, you have to purchase a license at least for 1 year, right? Or a lifetime license, depending on whatever subscription model it is. Compare that to if you are in cloud, you pay for the resources per hour. There are other pricing models as well, but typically per hour, and those include the licensing cost. Moving on, very important, you can now deploy your application globally in minutes. So let's say you have an e-commerce application, you have your user base in Asia, in India, as well as in US, as well as in Australia. We said that the cloud providers have different data centers, and they give you different data centers all around the world. Example of AWS have their data centers in 22 cities all around the world. in US, in Europe, in Australia, in Asia, Asia Pacific, Japan, so on and so forth. So depending on your user base now, it is very easy. Just a matter of few clicks, you can deploy your applications in servers in Mumbai as well as in servers in US. Just few clicks. So easy. Cloud solutions are generally more reliable. So just a while back I was talking about, if you have a file, you can store your file in cloud provider's data center rather than in your own laptop or desktop. Why? Cloud providers or cloud solutions are generally more reliable. Example I'll take about the storing file. There is one service called as S3 service in AWS that allows you to store files in AWS's data center. What it gives you is immense reliability. It gives you a reliability or durability of 99.99999, 11 nines. What that means is AWS claims if you store 10,000 files with them, the chances of you losing one file out of that 10,000 file is once in 10,000 years. And the reason why they achieve that high reliability, that high durability, is because you upload one file, they maintain multiple copies of your file. In case of S3, typically 6 copies of your files are maintained in 3 different locations, in 6 different data centers, right? So that if things goes wrong, even in one data center, doesn't matter, even in one location, even in one city, doesn't matter, your file is replicated across multiple locations, so you get much higher durability, reliability. Can you achieve this in your own on-premise? Yes, you can, but for that you will require lot much more investment. Next comes the security aspect. Cloud offerings are extremely secure. Just a while back I was talking about cloud providers have multiple data centers all around the world. AWS has data centers in 22 cities. All we know that yes, their data center is present in one city, let's say Mumbai, or they have data centers in Mumbai or in Singapore, but nobody actually knows the address of their data center, the postal address of their data center. That's for security reasons, it's been kept secure. Not only that, when you create your resources in their data centers, let's say you upload your files in their data centers, you can say that hey, please encrypt my file before you store it, so that even a cloud provider's employee cannot make sense of your file. Now when it comes to encrypting your file, you can ask AWS to use its own key for encrypting the file, or you can provide your own key for encryption of the file as well. When it comes to other resources like databases, you can say hey, please encrypt my whole database before you store it. When you create virtual machines or other services, you access those services using HTTPS connection. When you create virtual machines, you can create your virtual machines in your own virtual network, and you can isolate this virtual network to such an extent that your virtual machines cannot even have internet connection to it. So to that level you can make your resources secured. Imagine a virtual machine running in AWS but having no internet connection. If you wish, you can do so. Maybe that virtual machine is just used for hosting your database, and other web servers would access it to retrieve data from your database. A completely isolated, completely private virtual machine. And along with that, very important aspect is when you go for a cloud offering, you get a whole ecosystem of other services that you can use to make your application, to make your solution more reliable. Example, when I talk about AWS, and I will always talk about AWS because I'm an AWS guy. AWS, you can use a service called as EC2 to create virtual machines. But along with that, AWS has other supporting services, something like a service called as CloudWatch. This service creates metrics for your resources. So a CloudWatch service will give you information of the CPU utilization of the virtual machine. How much CPU is consumed, how much data is moving in, how much data is moving out. You have other services in AWS called as CloudTrail service, which keeps a track of the usage of your different AWS services, which will give you an information. Hey, Saif logged into your account at 10 a.m. from Mumbai and tried to create a virtual machine. And by the way, whether that operation was successful or not, right? So all these other services that gives you the monitoring capability, the auditing capability, the security capability. There is a service called as IAM, with which you can create different users and give different permissions to different users. All this comes along with the core services that you are going to use. Imagine if you don't use a cloud provider, then all these supporting services also you'll have to develop it yourself. So with that, I believe things should be more clearer as to what is cloud computing and what are its benefits. Now, moving on, we'll now talk about why exactly AWS. When you talk about cloud computing also, there are different public cloud providers. You have AWS, Amazon Web Services, you have Microsoft, you have Google's GCP, Microsoft Azure, and then you have other cloud providers. Why to go for AWS? This is the Gartner's Magic Quadrant. The x-axis talks about uh, the capability to execute, and the y-axis talks about the completeness of vision. And here you can see is, as per Gartner's analysis, AWS is the market leader compared to all other public cloud offerings. All right. So with that, we'll stop this recording now. Next, we will talk about the different use cases. Where would you be using AWS? So we will talk about the different services. Now there are 90 plus services. We'll talk about some core 30-35 services, one-liners as to what is their use case and where you'd use it, that in our next recording. Thanks for watching. Bye-bye.